Hi friends, it's nice to meet you again through this Learn Logistics video. You can go through all the videos through the above website www.harilogisticsacademy.com, and please send your suggestions and comments to the above email ID logisticshari2020@gmail.com. This will enable to give more improved videos in future. Now we'll go to the subject. On the transportation, the next mode is the cable. The cable transportation is used for various purposes. One is for electrical distribution. Second is cable transport. There is tramways, rope cars, sky lifts. There are other various ways of cable transportations. 3 is the telecommunication networks, which includes televisions, phones, internet, microwave, other networks. The above are commonly used in all countries. In this also, there are various types available. Networking through overhead towers, laying on the ground, laying underground direct by digging or by making tunnels, then by radio waves, wireless networkings, etc. The power cable is an electrical cable, an assembly of one or more electrical conductors, usually held together with an overall sheath. The assembly is used for transmission of electrical power. Power cables may be installed as permanent wiring within the buildings, buried in the ground, run over it, or exposed. Power cables that are bundled inside thermoplastic sheathing and that are intended to be run inside a building are known as NM-B, non-metallic sheathed building cable. The flexible power cables are used for portable devices, mobile tools, and machinery. There are a variety of ways to install power distribution cables. Each method ensures distribution of power with a unique degree of reliability, safety, economy, and quality for any specific set of conditions. These conditions include the electrical characteristics of the power system, the distance and terrain of distribution, and the expected mechanical and environmental conditions. The first power distribution system developed by Thomas Edison in 1882 in New York City used copper rods wrapped in jute and placed in rigid pipes filled with a bituminous compound. Although vulcanized rubber had been patented by Charles Goodyear in 1844, it was not applied to cable insulation until the 1880s, when it was used for lighting circuits. Rubber insulated cable was used for 11,000 volt circuits in 1897, installed for the Niagara Falls Power Project. Mass impregnated paper insulated medium voltage cables were commercially practical by 1895 during World War II. Several varieties of synthetic rubber and polyethylene insulation were applied to cables. Ely bare and cloth covered wires installed with staples, knob and tube wiring in 1880s till 1930s using asphalt saturated cloth or later rubber insulation. Armor cable, known by the genericized trademark BX, flexible steel sheath with two cloth covered. Rubber insulated conductors introduced in 1906 but more expensive than open single conductors. Rubber insulated wires with the jackets of woven cotton cloth, usually impregnated with tar. Waxed paper filler introduced in 1922. Modern 2 or 3 wire plus ground PVC insulated cable, example NM-B, known under the trade name Romex, is invented in the early 1920s. Aluminium wire was used in the 1960s and 70s as a cheap replacement for copper and is still used today. But this is now considered unsafe without proper installation due to corrosion, softness and creeping of connection. Asbestos was used as an insulator electricity in some cloth wires from the 1920s to 1970s. Tech cable, a PVC sheathed armored cable, was used. Cables consists of three major components: conductors, insulation, protective jacket. The makeup of individual cables varies according to application. The construction and material are determined by three main factors: working voltage, determining the thickness of the insulation; current carrying capacity, determining the cross-sectional size of the conductors; environmental conditions such as temperature, water, chemical or sunlight exposure; and mechanical impact, determining the form and composition of the outer cable jacket. Cables for direct burial or for exposed installations may also include metal armor in the form of wires spiraled around the cable or a corrugated tape wrapped around it. The armor may be made of steel or aluminum, and although connected to earth ground, is not intended to carry current during normal operation. Electrical power cables are sometimes installed in raceways, including electrical conduit and cable trays, which may contain one or more conductors. When it is intended to be used inside a building, non-metallic sheathed building cable, that means NM-B, consists of two or more wire conductors plus a grounding conductor enclosed inside a thermoplastic insulation sheath that is heat resistant. It has advantages over armored building cable because it's lighter, easier to handle, and its sheathing is easier to work with. Power cables use standard copper or aluminum conductors, although small power cables may use solid conductors in sizes of up to 1/0. Material specification for the cable's jacket will often consider resistance to water, oil, sunlight, underground conditions, chemical, vapors, impact, fire or high temperature. In nuclear industry applications, the cable may have special requirements for ionizing radiation resistance. There are various types of cable laying. One is open wire. Open wire construction consists of uninsulated conductors on insulators which are mounted on poles or structures. The conductor may be bare or it may have a thin covering for protection from corrosion or abrasion. The attractive features of this method are its low initial cost and the fact that damage can be detected and repaired quickly. Two is a aerial cable. Aerial cable consists of fully insulated conductors suspended above the ground. This type of installation is used increasingly, generally for replacing open wiring, where it provides greater safety and reliability and requires less space. 3 is above ground conduits. Rigid steel conduit systems offer the highest degree of mechanical protection available in above ground conduit systems. Unfortunately, this is also a relatively high cost system. For this reason, their use is being superseded where possible by other types of conduit and wiring systems. Fourth is the underground ducts. Underground ducts are used where it's necessary to provide a high degree of safety and mechanical protection, or where above ground conductors would be unattractive. 5 is a direct burial. Cables may be buried directly in the ground where permitted by codes and only in areas that are rarely disturbed. The cables used must be suitable for this purpose, that is resistant to moisture, crushing, soil contaminated and insect and rodent damage. While direct buried cable cannot be readily added to or maintained, the current carrying capacity is usually greater than that of a cables in ducts. 6 is underwater or submarine cable. Submarine cable is used only when no other cable system can be used. It supplies circuits that must cross expanses of water and swampy terrain. Grounding of cable system. For safety and reliable operation, the shields and metallic sheets of power cables must be grounded. Without such grounding, shields would operate at a potential considerably above ground. Thus, they would be hazardous to touch and would incur rapid degradation of the jacket or other material intervening between shield and ground. Relatively recent advances in the design and operating characteristics of the cable, fault location, equipment and subsequent repair methods and material have diminished the maintenance problem. An important challenge facing energy distribution companies will be adapting their business model to new technologies and innovation trends. In this context, adapting to the client's needs and improving operational efficiency will be key. 7 most relevant upcoming technological innovations on energy distribution may be: 1. Inclusion of distribution automation. 2. Energy storage. 3. Provision of air intelligence services to customers. 4. Cyber security. 5. Microgrids and virtual power plants. 6. Software for grid management. 7 is social media automated messaging. In conclusion, I would like to say the cabling network has come in a long way for electrical distribution and telecommunication network. Present world cannot sustain without these two important mode of transportation which were in use from 19th century. Let developments taken place in these and further more and more developments and innovations are underway. Keeping in mind the first safety, smart and economy, the developments are taking place. The key drivers of the smart grid in India are supply shortfalls, AT&C losses, that is aggregate technical and commercial losses. 3 is renewable energy. 4 is electrification. 5 is demand side management. 6 smart grid initiatives. So I feel with this Already government is very well under progress on these key drivers, and we may be producing excessive electricities in certain areas, and certain areas again the progress is on the way to meet the power demands of Indian consumers. Thank you, friends. As already I mentioned, your comments are welcome. Kindly send it on the above email ID logisticsarray2020@gmail.com. Hope you will benefit from this. We look forward for more interactions in future. You may subscribe this YouTube video to enable you to get the notifications of future videos. Thank you.